So now we'll be doing November 2022 paper 1, question 7, and it is on calculus. The first question is asking us to determine f prime of x from first principle if we are given f of x being x squared plus x. From first principle, always what they're looking for is for us to determine the differential of f at x using this formula. So this will be in your formula sheet. So it's the f of x as the limit of h tends to 0 of f of x plus h minus f of x all over the h itself. So our h here and here are tending to 0. Now we need to substitute in what f of x plus h is and what f of x is. So f of x plus h, given that f of x is that, so wherever in the f of x, wherever we see an x, instead of writing x, we write x plus h. So then that gives us x plus h all squared. This is that part there. Plus, we have an x here, but we're not looking for f of x. We're looking for f of x plus h. Therefore, it becomes x plus h. And then we minus the normal f of x, the original f of x that we were given. It's x squared. It has to be in brackets. Plus h, plus x rather, all over h. Right. Now we're just going to be solving for that. This becomes x squared plus 2xh plus x plus h minus x squared minus x. We do nothing to the h. And now that's the limit of h tends to 0. X squared and x squared cancel each other out. We have 2xh. We have the plus x and the minus x canceling each other out, and we're left with h. And this is all over h. So here at the top here we have 2xh plus h. So we can see that we have a common factor of h. So that gives us the limit as h tends to 0 of h into 2x plus 1. And what you can do at this step is for you to just multiply out the h just to make sure, as a sense check, to make sure that you go back to the initial 2xh plus h. Now we can cancel out the h's, and this gives us the limit as h tends to 0 of 2x plus 1. We now then drop the limit of h tends to 0 because our function in here no longer contains h. Therefore, our answer then becomes 2x plus 1. So that was using the principle, our first principles. Now, here in 7.2, they just said determine f prime of x if we have x being 2 to the 2x to the 5, 3x to the 4 plus 8x. So they didn't give us a restriction that we must use first principles. So we can go about it however we want, but we will not be going there, because here the mark allocation that we have is 3, and on the top question here the mark allocation is 5, and that tells us the level of effort that we need to put in. Now, what this then gives us is f prime of x is, now what we do is we say that that power there comes down to multiply out with the 2, and then that x, the x remains, and then the power that we used before we have to subtract 1. We're going to do the same, that 4 comes down to multiply out with the 3, and that 4 that was up there is then, as we subtract 1 from it, plus the 1 that is up there comes down to multiply with 8, and the 1 that is there, we subtract 1 from it. And just to a bit of a recap is that if x, or whatever variable we're working with, doesn't have a power, that means it's that variable to the power of 1. Now, as we are solving for this, this then becomes 10 to the x, 10x to the 4 minus 12x to 3 plus 8. So then that is our answer. Now we have another question, and that question requires us to work out the concavity of a function at a particular point. So now they're telling us that this is 7.3. They're telling us that the tangent to g of x equal to ax to the 3 plus 3x to the 2 plus bx plus c, and they're telling us that it has a minimum gradient at this particular point, which is -1 and -7. If you can visualize where -1, -7 is at, -1, -7 would be in the third quadrant, where both x and y are negative. Now the question then says, for which values of x will g concave up? And this is a 4-mark question, just to let us know the level of effort we need to do. Now, first and foremost, we need to differentiate g of x. So here we're not going to use the first principle. We're going to use the method that we just used now. And what g of x then gives us is 3ax to the 2 plus 6x plus b. Because c is a constant, c falls away. And then for concavity, we need to take the second differential, and the second differential of g of x then becomes 6ax plus 6, and b falls away because it's a constant in this case. Now, we have our our g differentiated twice. Now what we need to do is the following. At this point, our x is -1. So we need to find our double differential of g of x where x is -1. And that gives us 6a multiplied by -1 plus 6. And we have to then equate it to 0 because we are looking for the minimum gradient. Okay. And then if we have that, when we solve for a, so 6 negative 6a, when we multiply this out, plus 6 equal to 0. What we are going to do is to say negative 6a equal to negative 6, and then our a is 1. Right. So we're looking for the values of x where g will concave up. So for concave up, we will need to find for what values of x where the double differential of g of x is greater than 0, because it's for concave up. Right. Now what we are going to do, we already have our g double prime of x, which is 6ax plus 6. So we have 6ax plus 6 greater than 0. But we've already found what a is. So we put a there and it multiplies out to give us 6x plus 6 greater than 0. 6x now being greater than -6, taking the 6 to the other side, and then dividing both sides by positive 6, and then x must be greater than -1. So we are dividing by a positive number, so that inequality sign remains the same. So to answer the question, for what values of x will this function concave up? And that will be for all values where x is greater than -1.